Okay, this will be a video of how I have no electric bill. So I am net zero with respect to electric. So this is Webster's definition of net zero. In layman's speak, it's producing as much energy as you use or producing more. So in my case, I'm producing more than I use. So this is the definition of net. It's your consumption minus your production. So if your consumption equals your production, then you basically balance out. You have a net zero, meaning you use as much as you consume. So in most areas, you should not have an electric bill. So let's talk a little bit about electrical engineering convention and energy. Energy has signs associated with it. Anytime you see a positive sign, if you're looking at your utility bill, or no sign at all, that kind of implies positive, that means you're consuming energy. So anytime energy is being consumed in the home, the utility views that as a positive value. Contrary to that, if you look at a solar system, such as a solar array that's just connected to the grid, it produces what the utility sees as negative energy. And there's no such thing as negative energy, but the utility views the negative sign as which direction the energy flows. So if you have a solar system and it's just powering the grid, it's backfeeding all that energy to the grid, the utility company will see that value is negative. It's basically showing, the sign is showing which way the energy is traveling. If it's traveling into your house, that means it's positive. If it's traveling out of your house, that means it's negative. So with that being said, at the end of the month, most utilities companies will look at your meter and they'll look at the production and they'll look at the consumption. If the consumption is greater than the production, you'll get a bill. If your production is greater than your consumption, normally you'll get a credit. Now this is kind of different with each utility, but in a net zero case, after 12 months, if you've acquired enough credits, then you will have no utility bill, which is the situation that I'm in for my electric bill. And I'm going to show you how this works and what I've done. Okay, here's an example of a farm of air conditioners that would consume energy. So here's an example of a solar system. If it was just connected to the grid and not connected to anything else, it would produce negative energy, or it would basically say your power is flowing to the grid. So the utility company views that as negative. Now I see a lot of guys with a lot of elaborate systems out there. They show you the watts, the volts, the wind power, the batteries, everything in the kitchen sink. But what isn't shown is how much energy does that system produce? How much is it outputting and how much are you saving on your bills? All that elaborate stuff, when someone shows it to me, I really don't care. Ultimately, at the end of the day or at the end of the month or at the end of the year, how much energy does your system produce? And there's not a lot of guys that can tell you. So here are my electric bills. So I started off with my house in 2006, and slowly over the years it's been creeping up, and in 2011 it peaked at about 10,677 kilowatt hours. At that point I said enough, there's just too much energy usage, and I started looking for ways to how to reduce the energy profile of the house. So in 2014, you can see, I put on a solar system of 34 panels. It's about the middle of 2014, and if you can see, 2014 my energy usage dropped from 10,000 to 7,000. So in 2015, at the end of 2015, I bought a Nissan Leaf. So at the end of 2015, you can see that I used 3,100 kilowatt hours, down from 10,000. So really at the end of 2015, that's my energy usage from those 34 panels that I installed. Now I started really driving my Nissan Leaf in 2016, and that's why you see that uptick in energy usage. So at the end of 2016, I put on 20 more panels. I calculated how much energy I would need to power my car. I put on 20 more panels at the end of 2016, and so in 2017 you've seen that energy value now drop again. So basically, if you look at the history of my energy profile, what I'm pulling from the grid, I started off at about 6 megawatt hours or 6,000 kilowatt hours, and now I've reduced it to 1,255 kilowatt hours. So my total count for panels is 54 panels on my house. Now, a lot of people would kind of freak out and say, oh, that's a whole lot of panels, but really it's not. I literally power everything in my house by electricity. So this is a quicken snippet. So 2011 was the worst kilowatt hour consumption year I had. I used almost 10,000 kilowatt hours, which cost me roughly $1,020, and that doesn't include if I had my Leaf in 11 that I bought in 15. It'd be even higher than that. So now I've not only eliminated all my electric costs, I've also eliminated my fuel costs because I don't pay for gas anymore for my electric car. Okay, the next slides are going to be how much my solar panels produce, and it's really striking. If you look at all the negative values is showing what I'm producing. So I'm actually producing this with the panels, and if I were to get paid at, I think it's like 10 or 13 cents a kilowatt hour, this is how much money I'd make off my system. But unfortunately some of that energy gets used for the air conditioner and the microwave and the car and all the other stuff that I have, so I don't actually get this. But this is what the system in and of itself produces. So you can see there's a hefty amount of kilowatt hours that are being pumped out and pumped back into the grid. So I'm going to talk about the next couple of slides how much I'm actually netting, meaning after I use all my appliances at the end of the month, end of the year, what's my net. So production without consumption really means nothing, but here's what my system of 54 panels is actually producing. No bullshit. Here's what I'm doing, and I'll show you the rest. Okay, so now this is the actual net. This is what, after I use all the stuff that I use in my house, this is what I'm pumping back into the grid. So if you go from April to May on the left, you'll see that almost all the values are negative except for January, December, and November, and February. So those are the values where I'm not producing enough to actually provide my house all the power that it needs. So I have to actually draw from the grid. So here's the areas highlighted: November, December, January, and February. I don't produce enough electricity to power the whole house, so if I had to pay for electricity, this is what I'd pay. So that's roughly about $95 in electricity usage. So if you look at October, the last negative value, meaning the last month I overproduce, is October. November, December, January, and February, I don't overproduce, so I'd have a bill. So my overproduction is about 6,200 and something kilowatt hours. Now that actually carries over, and the utility pays me 1/5 of what I produce, but that's a whole nother story. So at the end of October, I had a $108 credit, which means I have no bill from October to February. So the overproduction months covered me over for the months I didn't produce enough, and now at the end of February I have no bill. Alright, so that's the front side of my house. I got about 15 solar panels up there, and they've been working great. They look great. And this is kind of the back side of the house. I think I got some 14 or 15 odd panels there, and this is kind of a video of that. And you can see they're really clean. They've been up there for almost 6 years now, and they've been working great, no problems. This is the south side of my house. I have another some odd 19, 20 panels over there, and they've been working great as well. Okay, now we'll dive into the system costs, which nobody ever wants to talk about, but here they are. So not having a gas car saves me about $2,300 a month. So this is an export for Quicken from what I've been using for the last 10 years to drive my truck, and it averages about $2,200 a month. Okay, here's the accounting aspect of this. So I did this in two phases. The first phase, I bought 34 solar panels and microinverters, which cost me $15,000. And then I'm going to lump everything else as permits, junction boxes, wiring, racking, tools, washers, nuts, all that kind of stuff. That's going to be lumped in as everything else. So that was about $7,000. And so the system total for phase one was about $23,700. Now I got a 30% tax credit, which was $7,000 something dollars. And I also got a $17,000, $900 roughly, a utility rebate. That brought me down to $1,327, and that's negative, meaning I'm ahead $1,327. The utility company paid me to put in my own solar system, so there was immediate payback. Now phase 2, I added 20 more panels for my car. Those panels cost me $9,000 roughly, and everything else was $3,156. So the everything else cost went down because now I don't have to put in all the junction boxes, all the switches, all the fuses, all the other stuff that I had to originally put in for the first round. I already had that. All I had to do is basically tap in to the existing system because it was designed to have an upgradable capacity, and that's why my everything else costs, so to speak, are a lot lower than the original everything else cost. So that system pre-tax credit cost me $12,225, or I'm sorry, $12,255. I had a 30% tax credit, which took off $3,600 roughly dollars, and I didn't have a utility credit, so my final cost for that system was roughly $8,500. So now when I add the two costs together from phase 1, which was $1,327, that wasn't a cost. They actually paid me $1,327 to put the system in after I paid for everything. And what actually phase 2 cost me was $8,579. That's what I had to pay out of pocket. Now when I combine those, that leaves me with my total 1 phase cost and my total 2 phase cost of $7,252. Now since I'm not paying electricity costs anymore, I'm saving $1,020 in electricity costs. I'm also saving $2,263 in fuel savings because I'm not driving a gas car anymore. So those two savings combined save me $3,283 a year. Now if I took those total energy savings and divided it into the combined phase 1 and phase 2 costs, that would give me a payback time or a return on investment of 2.2 years. So in 2.2 years that whole system has paid for itself. So there you have it, a solar system that can produce enough energy for your entire house. The next couple series I'm going to do is how to kind of go about getting the net zero. You just don't want to plop a bunch of solar panels down and kind of hope and wish and want. You want to kind of approach this from a granular standpoint and figure out how much energy you're using and try to get your energy use down first before you get a solar system.